Good afternoon and good morning to those of you out west. Welcome to today's webinar from Metal Architecture Magazine and AEP SPAN. My name is Stacy Ranella. I'm the editor-in-chief for Metal Architecture, and I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started, it may take up to 5 business days if you're requiring a certificate, so keep an eye out on your inbox and don't forget to check your spam or junk folder. If you have any questions during today's webinar, please enter them using the Q&A section, which you can find at the bottom of your Zoom window. We will address as many questions as possible during and at the end of the presentation. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, only use the Q&A instead. If you're experiencing any technical difficulties during the webinar, you can enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's webinar is being recorded and will be available on Metal Architecture's website by this time next week. Now I'd like to introduce our speaker, Jeff Medeiros. Jeff is the architectural representative for AEP SPAN and is a licensed contractor who has been supporting architects in California for more than 20 years. Jeff can spec write, assist in detailed drawing, and aid in product selection or any aspect of the design build process from initial design to complete bid-ready documents. He's fluent in building code, bid laws, and contract code. He provides architects with a full range of services from conception through bid. He holds various degrees, including law and society from UC Santa Barbara, Japanese from Waseda University in Tokyo, and he attended McGeorge School of Law in Sacramento. Jeff is fluent in all types of roofing systems, built up and torch applied, hot and cold process, and restoration coatings such as silicone urethanes and acrylics single ply roofing. He is also fluent in all forms of metal applications, including roof wall coping and soffit, as well as flashing trim. Jeff made the move to AEP SPAN over 7 years ago after spending years with a competitor and plans to stay on through retirement. In this webinar, Jeff will discuss metal roof systems, design and installation considerations. Designing to accommodate thermal movement is just one of many critical details for the long-term success of metal roof installation. This webinar explores specific considerations and architectural details that impact project requirements. Jeff, we appreciate you joining us today. Please take it away.
Good morning, everyone. How are you all doing? Do want to preface this by letting you know I'm currently traveling in a hotel, so hopefully this comes through clear. If there's any issues, I'll be right back on. This is the first slide, and I'm going to go to the second that shows the CES Learning Units. You will all be receiving learning units. Balls in your court to get those over. This is the required slide, so let's jump into it. All right, the main thing that I want to talk about in this presentation is really architectural roofing versus industrial roofing. Architectural roofing is going to be the concealed fasteners, while industrial roofing is going to be the exposed fastener. So that's a major takeaway that I want you to pay attention to, okay? So again, architectural, concealed, industrial is exposed, all right? Okay. So architectural roofing systems are generally the more clean ones that you see, standing seam and so on. If you're going to translate that into wall panels, it's your concealed fastener wall panels. Architectural roofing generally does not need a substrate beneath it, so it can span open purlin. This is what you used over a conditioned space most of the time, or on walls where you have changing profiles and so on. For industrial, also known as exposed, right? Generally speaking, those are over pre-engineered metal buildings, non-conditioned spaces, and they're much less expensive as well. So the industrial roof systems are going to be your corrugated through fastened, okay? Generally speaking, you don't want to use industrial roof systems over a conditioned space because you're putting holes through the fasteners, right? I'm going to skip past this real quick. Okay, so exposed fasteners by definition. We're going to talk about this first. The industrial roofing systems, the industrial wall panel systems. They're through fastened. You're putting a fastener through the panel to attach it to the substrate behind it. Okay, so that's a hole in the panel. They're nestable. And what I mean by that is the corrugations, and I don't care what corrugations you have, whether it's a sine wave, a trapezoidal panel, a box rib, a V panel, whatever. It's all the same, right? Sine wave to box, whatever. they're all going to have a repeating corrugation, whatever that corrugation may be. And because of that, they're nestable, so they can ship on a pallet, alternating back and forth. They're less expensive to ship. Third thing is they rely on laps and sealant for waterproofing. So if you're going to lap a 36-inch wide panel on a wall, on a roof, it has to shingle, right? You lap it with sealant and a lap. Easy. They are quite simple to put up. I could grab a couple of you from the participants on this call. We could go out with a 6-pack of beer and a pizza. We can put those up. You hold it, I'll run some fasteners through it, right? It's not too difficult. Whereas architectural panels are much more difficult. Very, very durable because there's a repeated sine wave or a repeated box rib. If they get hit or there's a human impact, there's a predefined point where the metal is going to flex. And so it's less chances for oil canning, I should say. They can be installed vertically, they can be installed horizontally, and they come in a varying range of gauges. And what I mean by that is, if you have like a equestrian building, you might do 28 gauge, right? Or 26 gauge. Or if you have a wall panel outside of a bar, you might do 22 gauge or 20 gauge so it can withstand some impact. So key takeaway of this, exposed industrial, same thing. Through fastened, they have holes through the panel, nestable and laps and sealant. So this is what I mean by through fastened, right? If you look at this sine wave right here where my mouse is, they're going to lap. Fastener goes through. So some of you out there may be thinking, hey, Jeff, that's cool, but if you're putting a fastener through metal, how does it move? Very astute question from my ether audience, right? If you're going to pin those panels, and metal likes to move, expand and contract, it's going to have to expand and contract within the corrugation. So it's a predefined point for it to flex. However, just like when a nail backs out of a fence, because the wood gets wet and expands and shrinks and so on, and that nail head heats up and cools off, that nail backs out. Same thing happens here. There's always the possibility that the fasteners can back out, and if they do, you have to go up, replace them with an oversized fastener, or the expansion and contraction of the panels can create an elongated hole. So they're going to expand and contract. That fastener is going to pin it, and it's going to make a little hole around it. So those are two things to be cautious of when you're installing exposed or industrial fastening systems. In other cases, you want a concealed fastener panel. I like to use these over conditioned spaces because there's no holes through the panel, right? This is the antithesis of everything industrial, quote unquote, exposed. This does not rely on laps and sealant, right? It relies on a panel engagement. They're not nestable. You can't ship them on a pallet because you can't fit a 16-inch wide panel inside of a 16-inch wide panel. It doesn't work. Some of you might be thinking that, but you can lap panels, and I'll teach you that down the road. There's very limited conditions where you can do this, but you can't ship them that way, right? So everything is the opposite. Concealed fastener, no laps and sealant, and no through fasteners, right? So it's the opposite of industrial / exposed. So there's a couple different styles of standing seam roofing. And again, these can be used on the walls. You can put standing seam on the walls, no problem. It's vertical. There's a snap style panel. If you look closely here, there's one panel that has a male leg, one panel that has a female leg. They interlock to the adjacent panel. You push and click, done deal. There's mechanically seamed panels where one panel leg fits inside the other, and then a mechanical seamer is run down and it seams the panel over either 90 or 180. So the difference between the 90 and the 180 is just how far that panel seamed over. So if you're looking in plan view, do you want an 1.5 inch reveal, or do you want, 3/8 of an inch, or sorry, 1.25 inches or 3/8 of an inch? So snap style, mechanically seam, and then the other ones are batten seam. So if you look at the bottom here, these are both the same. One's a narrow batten, one's a wide batten, but let's look at the wide batten panel. So as you see, there's that clip that engages the panel legs, and there's a fastener in the middle of that. You might be thinking to yourself, the panels don't positively engage each other without the batten, and you're correct. So there is technically a gap between those panels. So because of that, the batten seams are typically limited to a 3/12 slope and do require a solid substrate. There is an exception for this if you move to a T-seam panel or a bulb seam panel. But for high-level understanding, snap, mechanically seamed, or batten, those are your three applications, right? So again, no visible fasteners is what we're after here. So the clips, there's a one-piece clip that allows the panel to engage it, and it has unlimited thermal movement. The panel can expand down slope and up slope as it thermally cycles. So you can technically do, a 200-foot long panel with this, no problem. The mechanically seamed panels, the large majority of them, seam into the clip. So if you're thinking about this, the one that's rolled into the clip, that has rolled metal into a clip, should have a much higher performance, and you'd be correct. The issue with this is when you mechanically seam into a clip, the clip has to be able to slide back and forth. And so you have plus or minus 1 inch of movement. So metal is the party animal of building materials, right? Metal likes to move, it likes to dance, it likes to party. Steel will move 1/8 of an inch over a 10-foot stick, whereas aluminum will move 1/4 of an inch over a 10-foot stick. So if you have plus or minus 1 inch of thermal movement, you have roughly an 80-foot long panel that you can install with these clips. There are ways around that to make them longer, but you are limited by the amount of movement. So if you have a shed roof over a gym, there are special considerations that must be taken in when you're doing a mechanically seamed panel. Now, the thing about this is, if I'm going to back up real quick, the snap style panels are good down to about 1/12 slope. Mechanically seamed can go down to a 1/4 slope. That's the lowest slope allowed under code without moving to coal tar pitch. But coal tar pitch gives us cancer, so we don't like coal tar pitch. We like a 1/4 slope with mechanically seamed. So 1/12 for the snap style, 1/4 which is the lowest slope allowed under code, and then battens is about 3/12. All right, moving on. So bearing plates. What is a bearing plate? So in certain instances, you're going to want to install a mechanically seamed panel or a snap lock panel, standing seam panel, concealed fastener directly over polyiso. So let's take steel deck followed by polyiso, and you don't want to put a exterior jip. So you're going to have to use a bearing plate. And the reason for this is because if you look at the footprint of the clip, when the fasteners are under tension, the clip will sink into the polyiso because polyiso has a compressive strength of 25 psi. Not a good substrate, right? So the bearing plate acts like a snowshoe. Clip just fits into it. The bearing plate's pre-punched. It's got holes and little tabs that are raised to hold that clip in place. So it doesn't add cost to the job. When the contractors are up there, they grab a clip from one box, a bearing plate from another box, and run fasteners through. But what happens is that bearing plate, which is 4x6 essentially, distributes the footprint when it's under tension over a larger surface area, so it won't sink into the polyiso. The other option in lieu of a bearing plate is to put an exterior half-inch jip like a Densdeck Prime, or so on, which has a compressive strength of 900 psi, and then you do not need a bearing plate. So bearing plates are snowshoes over polyiso. All right. Continuous standing seam panels can be used, like I said, for as long a slope as you want, but you need to be aware of what's going on. And here's what I mean by this, okay? I'm going to skip ahead. Okay. If continuous standing seam panels are required, all right, you have to have enough room to run them out. So number one, they have to be roll formed on site because you can't ship a 200-foot long panel in, right? So roll form on site, which requires a roll form operator and a truck driver. You have to have enough room to roll them out behind the trailer. You have to have enough room to stage them. Then how do you get them on a roof that looks like this, or that looks like this huge structure behind me? Well, it's called a spreader bar. And the spreader bar is the photo on the right that goes from 1 pick point to 2 pick points to 2 4 pick points to 2 4 6 8 pick points. And so the panels don't bow in the middle when you're lifting them. Well, let's add in some labor costs now. You have to have one person per 10-foot length of the panel to move it. That's metal workers' wages, expensive. You have to have a site access, a flagman. You have to have a crane operator. And have you looked into how much crane operators get paid? It's like heart surgeon level, right? So you have to have that, a crane operator, that cost. You have to have perfect weather conditions. And what I mean by this is if you're a contractor and you have a lift during wind and it blows that panel, and those panels get torqued or bent, you aren't out a 10-foot long panel that's easy to replace. You're out, you know, 150 foot or a 200-foot long panel. That is a huge, huge hit to your pocketbook, right? Because you're responsible for that. So if you're going to do on-site roll forming, I'm going to go back again for domed or arched panels, excuse me, or long length panels like are shown here, you have to be aware of the costs associated. Okay. Moving on. Substrates. Metal will follow the substrate. The picture in the bottom corner of the orange panels show that it will cancel it. It'll go right over the substrate and follow it. So it has to be a properly prepared substrate. Underlayment. Underlayment should always be the following: a peel and stick, high temperature, 40 mil minimum pretty much, and it's going to be your modified underlayments, right? So in this rendering on the left, you have your metal deck, your polyiso. Notice there's no bearing plates here. They chose to go with an exterior jip. Underlayment, then clips and fasteners, okay? And I know you might be saying to yourself, Jeff, but I use asphalt and impregnated felt for my roofing systems, and I've never had an issue. Well, let me show you this. This is what can happen to an asphalt impregnated felt under high temperatures. This is up in Redding, California. Gets very hot, gets very cold. The asphalt impregnated felt can reemulsify under hot temperatures and leak down the sides of your building. Thankfully, this one was on the inside of a coping cap, but can you imagine if you had specified this on a slope and it leaked down the outside of your structure? It wouldn't be good. So always use, again, a peel and stick, high temperature metal underlayment that's designed specifically for metal, so you don't end up with this. Okay. All right. Gauges. Exposed fastener roofing systems, you have a wide range of gauges. There's pre-engineered metal buildings that you can use light gauges on, like 26, 28, and so on. Architectural roof panels, concealed fastener for roof or walls, are generally 24, 22, or 20, or 18. Whatever metal you want to make them out of, fine. Aluminum, steel, we can do copper, all of it, but steel is the standard. And because if you think back to your materials class, excuse me, steel has a memory in sheet form. In sheet form, that is, steel will have a memory, meaning if you hit it, baseball lands on it, someone leans up against a wall panel to take a call, someone breaks up with their significant other and kicks it, it's going to have a memory. It'll pop back out, whereas aluminum will not. Think of your granddad's truck, right? Shopping cart hits the door in the parking lot. No problem. You know, we'll take it home and your grandfather will pop off the door panel and hammer it out and it'll be back to normal. Aluminum, you can't do that with it. So generally speaking, steel will always perform greater than aluminum. And what I mean by that is you can have less clips, less fasteners per your distance for wind uplift as compared to aluminum. So certain things to take into consideration there. Aluminum is good for certain applications, specifically where you have a corrosive environment like a paper mill or a salt shed or so on. Over a marine environment, it may not be the best option. I will touch on that in the paint section. But the gauges are, generally speaking, from 28 down to 18. You can go with 16 in certain instances, but maybe a special order. Okay, so real quick before I open up to questions, we've talked about concealed versus exposed fasteners, industrial versus architectural. I want you to remember those three things: the laps, the nesting and sealant, and so on. And then remember that underlayment. That's key takeaway there, right? Always use high temperature underlayment.
Okay, thank you for that, Jeff. Let's get to some questions. For the exposed fastener panels, where is the best place to fasten, at the high point or the low part of the corrugation? And which is best to reduce leaking?
So as a roofing panel, you always want to fasten through the high point, right, where it goes up instead of down, because all the runoff will come off that and go into the valleys and then run down. So very straightforward answer, fasten at the high point of whatever corrugation it is.
And are there any pros or cons between using a wide or narrow batten seam?
So yes, there is. A narrow batten seam will have a lower propensity to leak because the panels, which are just right angles, right? Like it looks like this. This panel engages this panel and the batten goes over the top. That gap is more narrow when the batten seam goes over the top. The wide panels may have a gap like this, right? This panel's angled into this panel and the batten's wider. There's a more exposed area. So if you want to go with a wide batten look, there's an option for a decorative wide batten trim on the snap panels where you snap and engage. You can put a wide batten trim over the top. So if it's, a more of a low slope or you're worried about leakage, you can always go decorative with a adjacent interlocking panel rather than a traditional batten seam.
Okay, does HTUL need to be all peel and stick on slopes over 412 or only at drip edges and valleys, then HT synthetic over remaining on steeper pitches?
So very advanced question. I'm going to give a high level answer for a lot of the people that are here. Gold star to you for whoever asked that. Generally speaking, under metal, regardless of slope, you always use a high temperature underlayment. Modified versus synthetic, that's going to be up to you. There's what this question is asking is there's certain underlayments that use a modifier. A modifier is a asphaltic based product that they add rubber to, which can be anything from SBS to SEBS to APP, but the modifier just means I've added rubber for like our high level discussion, right? Which makes it more elastic and stretchy versus synthetic, which does not use that. I'm going to leave that call up to you, but generally speaking, on underneath all metal panels, regardless of slope, even if you have to strap, it's okay to strap, right? Which is not laying it this way, but laying it this way. Always use a high temperature peel and stick underlayment. Stay away from the 30-pound felts, but there's a wide selection of compositions of that underlayment to select from.
Okay, let's do one more. And just a reminder, in case we can't get to all the questions, Jeff's contact info will be up at the end of the presentation for anyone that wants to get in touch. One more question, Jeff. For what type of buildings is it actually recommended to install metal roofing directly over polyiso?
Okay, so there's no recommendation whether to do that or not. It's how your assembly is going to go down. And so certain assemblies that don't require a fire rating, or you don't want an exterior gyp, you don't want the additional labor pass with the loading the gyp, laying out the gyp, installing the gyp with the fasteners, there's that cost. In certain assemblies, you can eliminate that gyp and go straight with polyiso. So the bearing plates are there only to distribute that footprint depending on whatever assembly you go with. So for example, over a metal deck, non-combustible, 2 inches of polyiso, pretty standard, 3 inches of polyiso. Do you need the gyp or not? You as the designer have to make that call, but we can accommodate either way you want to go. But there really is no recommendation of what type of building type it is. It is how your assembly is going to go. So if you have 8 inches of polyiso in some certain area, it's going to alter that entire assembly composition. So very good question. But it's left up to the intent of the designer. We can accommodate either or.
Okay, we will take some more questions in a little bit, but for now, we'll get back to Jeff's presentation.
All right. This picture that you see here is a coil of steel. If you're ever behind a truck carrying these, don't be behind it. Get out immediately. These are the most dangerous things on the road, bar none. A coil of steel is essentially, imagine a roll of toilet paper. Now make it 4 foot in width. Now make it metal. And that's what this is. It's just a big coil of sheet metal. There's generally 2 different coatings on steel. One is galvanized, One is galvalume zinc-alume. Galvalume, zinc-alume, same trade name, right? Like Tissues, Kleenex, or Kirkland to whatever brand that Costco sells, right? It's the same thing. The galvanized is 100% zinc. It's measured in the G30, G60, G90, which is a pound, which is a weight coating. The galvalume, zinc-alume is 55 to 45, right? So the corrosion protection comes from the aluminum, and the zinc component gives that sacrificial characteristic. Okay, very important here. Pay attention. This is a takeaway. Galvanized, industry-wide, have no substrate warranty. Okay. Galvalume, zinc-alume has a substrate warranty. This is industry-wide. All right. So this picture here is it being coated. It goes into a vat, out of a vat, through things, through rollers, and so on. So a galvanized, a zinc-alume galvalume, the 55 to 45, even if it's unpainted, you can get a 25, 30, or even a 40-year warranty on the metal, even unpainted. 60 G90, not warrantable at all. If you paint them, you can have the paint finish warranty over your substrate warranty with zinc-alume galvalume. If you use galvanized, your paint may have a warranty, but your substrate does not. So that means if your paint weathers or something happens, the substrate can rust and you have no coverage. Be aware of the differences in the base metals when you're specifying this, because if you're going, oh, why is this 15 cents more per square foot? Might be the substrate, right? I personally think zinc-alume galvalume is exponentially better than galvanized, but a lot of the manufacturers tend to use galvanized because it's cheaper. All right, paint systems. Once that coil is coated in galvanized or zinc-alume galvalume, it's painted. Polyester is the lowest end coating. Okay, you bump it up to SMPs, a silicone modified polyester. Then you bump that up one more time to a full Kynar system. Polyester may be a paint system that a lot of the roofing supply houses stock because it's cheap. Okay, so if you're going to specify a Kynar paint system for an architectural panel, concealed fastener, standing seam system in 22 gauge, the 22 gauge flat stock from the building supply house may not have that Kynar paint system. So what happens is if you make flashings and trims out of flat sheet not with the same paint system, let's pick white, the white's going to yellow out and look horrible. Your flashing and trim will look different than your actual Kynar paint system. So be very aware when you're specifying that you should specify that all sheet metal flashing and trim, flat stock, and so on should come from the same coil with the same paint system as the metal panels. In order to, number one, maintain an exact color match, right? Because not all cool Regal whites are the same color. And number two, a congruent paint finish warranty. So it's very important to know the difference between the paint systems, okay? All right, we don't want to touch more on this. So polyesters, we don't really generally use. SMPs are used on light gauge products. And I want you to think of a sheet of paper. If you're going to hold a sheet of paper out, it'll flop over, right? That's light gauge metal. Because it's so bendy and movy, you have to use a paint system that will flex with it. So SMPs are used. The higher gauges, the thicker gauges, 24, 22, 20, use Kynar. It's more like cardstock. So Kynar paint isn't flexible, as flexible as SMPs. And so Kynars are used on the thicker gauges, not on the thinner gauges, because it has to be able to move more. Okay. All right. What's this slide about? Oh, when you pair Kynar with an appropriate substrate, I mean, what? Fantastic performance, right? I've touched on that. Let's move on. Okay. So the metal comes in. It's then coated with zinc-alume galvalume or galvanized if you go with the subpar coating. Then the paint system goes on. The backer coat is always going to be an off-white or white polyester paint system. You're going, wait, Jeff, but you said polyester was the low end. Yes, it is. That's why it's on the back. Okay. Top can be Kynar. in whatever color, blue or whatever. Now, I'm hearing, I'm getting a question from the ether. Is Jeff? I'm doing a outside canopy, and I want the bottom the same color as the top. We can do that with a minimum order and extra cost and lead time. You can coat both sides. So when you look up, it'll be, I don't know, Amazon blue, right? Okay, so I talked about this as well. Paint systems are not the same. Check the warranty. Kynar has by far the best paint warranty system out there. Oh, now this just reminded me of something. Kynar paint systems use PVDF, right? PVDF, Kynar, Duratec, all the same thing. The electric car battery industry uses PVDF as a separator between the positive and negative side of a battery. The three major paint manufacturers, what, Sherman, PPG, and oh gosh, there's one more. The three major paint manufacturers don't have the same pull as Toyota and Tesla, obviously. So you may, I'm not saying you will, you may see Kynar go up in cost. Fear not. There's absolutely zero solution for that problem at this time or fear, right? So if it starts to go up, it is what it is. So the paint manufacturers right now are working on a better way to accommodate the PVDF or resin shortage that may come up. So you may see Kynar go up in price, and it's due to the electric car batteries and the same use of that resin. Hopefully they'll figure something out, because that's what they do, right? Just tuck that in the back of your head if that happens. Okay, sealants. There are sealants that like to see the daylight and sealants that don't, right? There's your vampire sealants that like the dark. That's called butyl or non-curing butyl. It can be tube applied. It can be sausage applied. It can be tape applied. The point is, non-curing butyl likes to stay dark. It doesn't like UV. If it sees UV, it'll break down. If it doesn't see UV, you're good to go. So butyl tape is shown right there. Again, this is buried in the metal. It will always stay sticky. So if you peel a roof off in 50 years and it's still sticky, that's what it's designed to do, right? In all other instances that see the sun, you do not use butyl in whatever form. You use a polyurethane, which is typically a single component urethane. Those can be tinted, and they're used to interface between metal and masonry, brick, stucco, whatever. So daylight, nighttime, right? Those are your two sealants with metal roofs. And again, this is the butyl tape. This is the butyl tube applied. And then your polyurethanes are what you see in a lot of exterior as well. And also keep in mind, polyurethanes moisture cure, so it likes to stay wet. That polyurethane is what's used under splash parks and so on. So it's very durable. Okay, material testing. Wind uplift test is a very common one with metal panels. It's the E1592 test to ultimate failure. Air and water infiltration behind the panel, and so on. But what I want to touch on here is the ASTM testing versus UL, okay? UL is pass, fail. ASTM is push to failure, okay? Think of it this way. UL is your realtor exam. Did you get 70%? You can sell a house, okay? Or let's put it in more morbid terms. I'm sorry to go this route, but let's say you're going to have a surgery done, or a loved one is going to have a surgery done. Do you want the surgeon working on your loved one, or you, that passed their test and can do it? I'm like, I'm good. I've done this before. Or do you want the highest ranked surgeon you can possibly find, right, to do your surgery? That's ASTM. And that's why ASTM is applied to your UES, Universal Evaluation Services, also known as IAPMO, also known as ICC, also known as ES services, all the same thing. It's push to failure. So keep that in the back of your head. Easy. Metal's recyclable. Moving on. Okay. Cool metal roofing. Jeff, what does cool roofing mean? Okay. Think of Tinkerbell. Yes, I said it. Tinkerbell. You know how when she flies, fairy dust comes off of her, right? This is how I wrap my head around this. Um, Tinkerbell flies over that paint vat and sprinkles magic fairy dust into the paint vat, which does not change the hue or the pigment, but it drops the overall, excuse me, raises the overall solar reflectance. Same color. Cool dark bronze is the same color as dark bronze. However, the reflectance is higher because magic fairy dust has been sprinkled into this vat, and it doesn't change the pigment. You don't see it, but that's what the word cool means before the color. It means a chemist with infinitely more wisdom and knowledge than me has figured out a way to add that magic fairy dust into the paint, not changing the color, but raising the SRI. So cool. All right. Different colors have different thermal emittances, different solar reflectance values, and depending on what your energy code is locally, you may or may not be able to use the certain color depending on what you're going for, the prescriptive or practical approach of attaining your energy code requirements. So what I mean by that is if you're going through that and you have a roof that is 2,400, 2,600 square feet over a conditioned space, under 2 and 12 slope, which is considered low slope, you may only be able to use white unless you meet certain other prongs to use different colors. So that's why this is here. Okay, Jeff, I want to mount PV to my metal roof. How do I do it? You do not put holes in it. You use a clamp. A clamp goes over the seam, has a set screw. You fasten it, and then you can install whatever you want over the top. You can install PV. You can install snow retention. You can install snow melt. You can install signage. You can install catwalk. You can install anything except, here's the except, fall protection. Okay. The companies that make seam clamps will say, we have tested this for fall protection. Yeah, they have. They've tested their connection to the roof. However, when you have a 6-foot roofer with a utility belt, right, and all of his tools up on the roof and they slip and fall off the roof, the forces that are experienced are exponential, and that roof will come down on top of them with the PV attached. Okay, you have to take into consideration the fastening of the PV to the roof to the substrate. It's like painting a wall, right? You have to prep the wall before you paint it, otherwise the paint's going to peel. So no roofing manufacturer is going to take into consideration the forces that are going to be experienced from your fall protection on their roof. It may require that you put one clip every 6 inches, right? Versus 4 foot on center. You don't want that expense. Always attach fall protection to the structure itself through a D-ring or a davit and use a pipe boot. Okay, attach anything you want through these clamps except for fall protection. So clamps go down, subframe goes down, PV goes on top. This is what it looks like, right? Awesome. So another question from the ether. We're going to say, hey, Jenny asked this question. Good question, Jenny. Jeff, won't putting PV on the roof create additional wind uplift? Jenny, great question. Yes, it will create additional wind uplift. However, the additional clamping force from the clamp on the seam negates that. There's calcs behind this. In 99% of all instances, it's negated. So there's that. Okay. Oh, always separate dissimilar metals, right? When you're installing PV, don't put open copper, right? Okay. So I know this is base level, but don't do it. Okay, solar panels can be installed pretty much over anything. Catwalk, fall protection, fall protection is the only thing you can't install, must be installed to the structure itself. All right, this is the end of section 2. Do we have any questions on paint systems and colors and so on?
Yes, we have a lot of questions. So I'm going to
Let's do it.
merge two questions into one here. How do different paint finishes such as Kynar or siliconized, did I say that properly? Siliconized polyester impact the longevity and appearance of a metal roof? And what is the cost increase from Kynar to siliconized?
Good questions. Gold stars to both of you. Stamp, stamp. Okay. SMPs generally have warranties of anywhere from 10 to 15 years. I've seen them as high as 20. The chalk and fade is not as good as Kynar. Current Kynar paint systems have up to a 40-year paint finish warranty. 40 years, okay? That's like, hey, your car has, a 50,000 mile warranty, but you don't throw your car away after 50,000 miles unless you like to lease. But generally speaking, right, it'll go 100, 150, 200,000 miles, right? Same with the Kynar paint systems. So if it's warranted that long and it won't fade past a certain amount, craze or chip, for 40 years, only then will you start to have certain fading looks to it, right? And that's why I'm going to touch on this other thing. Why it's absolutely imperative that you specify that your sheet metal flashing and trim and flat stock come from the same coil. Because if your cool regal white lasts for 40 years and your trim is from Diamond or RSG or whatever local paint roofing house that has this with a polyester paint system, 5 years maybe, it's going to weather totally different and look different. So you have to make sure you do that. Cost, paint system cost differential from an SMP to a Kynar, depending on volume, can be anywhere from, I'm not joking when I say this, 5 cents per square foot to 25 cents per square foot. There is not a big cost difference. There's not. But those paint systems have their place. SMPs are for the lighter gauges because they flex. But the thing is some contractors will source less expensive paint systems to save $150, right? Wherever they can. So just be aware of that. Not a large cost difference. Right now, again, the EV battery may change this, but right now, not a large cost difference.
What about the other fluoropolymer systems out there, like FEVE resin systems? Can these systems be used, and what is needed to do this?
Okay. Very advanced, but we got some real players on today's call. I like it. So there are other systems available. I'm not going to talk on those because by far the industry standard, by far, is Kynar for architectural metal systems. That's a rabbit hole that we can go down. If you're interested in having a conversation with me on that, email me on 101 because it's a very extensive answer there. But what I can say is the market is controlled and it is a market standard for Kynar paint systems versus the other paint systems. The three you're going to see are polyester, SMP, and Kynar, probably in 95, 96% of the cases.
Okay, we have a comment here. Something that will fail any metal roofing system is when panels are cut, but edges are left untreated. Can you respond to that, Jeff?
Yes, I can. That is not necessarily true. Okay, so there's a specific way to cut a metal panel. So let's say you have a roof that comes down like on almost a sawtooth, or you have to miter a panel or something. The correct way to cut a metal panel is with a shearing motion. Okay, a shearing motion. If you use a grinder wheel or etc., it will not put the proper edge. And what I mean by that is when you have a zinc aluminum panel, even if it's painted or not, because remember, you can warrant those zinc aluminum galvalume panels for 25, 30, 40 years actually now with no paint. With a shearing motion like this, it folds the edge. And so the edge that is not painted, paint on the top, paint on the bottom, even if it's bare, that edge is folded. If you use a grinding wheel or etc., it will not be. This is called out in SMACNA. It's called out in the installation instructions on the specifications, is use a shearing motion. That will preserve the edge. Mitering panels is not uncommon whatsoever. It's done on almost every job. Cutting trim, right? Shearing motion.
Okay, let's sneak one more question in here. Are there any maintenance considerations needed when choosing a paint system, such as polyester needing to be cleaned more often to prevent staining?
Interesting. First time I've gotten that. Really, paint systems are not serviceable. Like if you just leave them up there, right? You can pressure wash and clean them. So actually, I actually have had something in the past where they wanted to repaint a roofing system because the color wasn't what they wanted. They changed. They were bought by another company and they had to change from like a blue to, I want to say, a red. It was a pretty substantial paint color change. Scope of work for that was up on the roof with a pressure washer on a light setting, and you pressure wash with a simple green feed. So it was water and simple green to get the dirt and debris off of it prior to the painting prep. So my answer is no. There's no maintenance required with metal paint systems. Just be aware that they will start to fade over time at different rates depending on what paint system you use. If you want to clean it and paint it, it was a simple green feed with a pressure washer on a light setting prior to the prep, prior to the paint. Also keep in mind, we can do really any custom color you want. So if you wanted to do a 1980s style roller rink, right, with neon green and hot pink, if we're dating ourselves, you can do that. But the reds and the yellows that have a thinner pigment, just like painting a wall on the inside of your house, may require more coats to get that full color visible, whereas whites and grays and tans don't. So same thing applies with the metal pigments. Yellows, pinks, reds, more difficult than other colors.
Okay, and I think roller rinks have made a comeback, Jeff, so you're pretty current.
There you
And
go.
let's get back to your presentation.
All right, I'm going to skip over this pretty quickly because we're limited on time. So design and installation considerations. You can hear the wind. Wind is the major thing that makes metal roofing fail, okay? We can do, excuse me, we can do site-specific calcs for you. So if you have a project and you want clip spacing and you want to get the site-specific calcs, AAC 705, 710, 715, 716, 721, whatever your ASC, your 7 that you're adhering to, we can do those calcs for you, fill out a form, eave height, slope, roof run, and so on, building height, all that, we'll take it into consideration and kick you back calcs that you can get through the Department of State Architecture DSA that give you clip spacing, and you can use those in combination with the UES, like a IAPMO ICC, to get through state bat check. Okay. Uniform static air pressure difference. So again, UL is pass fail. Oh, factory mutual. Glad I saw that real quick. Factory mutual. Don't specify factory mutual unless you have an FM insured job. Okay. Factory mutual requires a significantly higher safety factor as opposed to non-FM insured jobs. If you're not an FM insured, you are going to add cost and over-engineer your roof to something insane. Don't do it unless you're FM certified. FM insured. Okay. Lapping. Oh, wait, no, hang on. This is air and water, 1680 and 1646. Metal panels do have air and water infiltration testing done through the seam. Also, I'm going to touch on the E2140. That's a static pressure head test, which is where the panels are lapped. Wait, Jeff, I thought you said we couldn't lap panels because they ship in the same width. I'll touch on that right now. But we do have testing for that, where if you need to lap a panel, it's flooded with, I believe, 12 inches of water, pressurized, and if anything comes through, it fails, right? Okay. IAPMO, UES, ICC. I touched on all this before. This is the pass-fail versus push to failure. I'm skipping this in interest of time. These are your values right here, where you can have your substrate on your side, say it's cold form steel grade 50. Then your gauge of your substrate, let's say it's 16 gauge, everything else disappears except for this row. 2 fasteners, here's your fastener size, and there's your pressures extrapolated out. This is what your ASTM testing can do, and that's why we can push it to failure. So this shows everything, and this is how you get through DSA back check. Okay. You can accommodate thermal movement of a metal panel. Again, they like to move, they like to dance. They're a very moving building material at the top, at the ridge, or at the bottom, or in the middle. Here's how I'm going to talk through this. Okay, so 90+% of roofing systems have drag fasteners at the ridge, like you see on the left, and the panel expands down slope to a joggle cleat so it can still stay engaged, and it expands and contracts like that. However, if you have a long run and you have to lap a panel, or you have an arch where you want to pin it in the middle, it has to float down both sides. If you have a mechanically seamed panel where the clip is rolled in, it has plus or minus 1 inch of movement. 80 feet on one side, 80 feet on the other side. You can fix it in the middle for a total overall length. So you can fix it in the middle, float up, and float down. Okay. This is what the eave condition looks like. It's a joggle cleat. The panel hems around the end and it expands down slope. Right? Wrong. How much time do we have? 8 minutes. Okay. I know a lot of you like this condition where you run a roof panel from the ridge to the eave, you cut the seams and you fold it down a wall. It looks very aesthetic, very modern, very pleasing. When you do this and you put kneecaps on, it creates a point of fixity. Okay, so if you put drag fasteners at the top, come down 40 feet, flip the panel and fold it, even if it's only a little mansard application like this right here, like a foot, 2 foot, or if it's the whole wall, that point of fixity will not allow the metal panel to expand and contract on the sloped portion. Not good. In this instance, you have to float the panel up slope with a floating ridge condition. Okay, absolutely imperative. If you cut the kneecaps like this, it must float up slope. Don't cut kneecaps in snowfall areas. Snow coming down the roof will rip them off, and the freeze thaw over time. We all know ice takes up more volume than water, liquid water. It'll pop it. Okay. The ridge. You see this step in the ridge cap right here? This step. That's how a floating ridge works. The ridge cap is allowed to get pushed in as the panels float up slope. Also, this is the same design for a vented ridge, right? Again, you use this with that kneecap transition when you have to float a panel up slope, or you have a pin in the middle and you're floating 80 foot or 80 foot down. Okay, where a fixed panel may be utilized. You can lap a panel. So you see these little marks right here in these panels that look like little bubbles or airplane canopies that taper back. That's called a swedge mark. The answer to your question of how you lap panels is you have to swedge them. It's a cool word, right? Swedge. You take the end of the panel with a tool that you step on and push, and it does this. It goes boop and makes them go just a little closer together, which allows you to lap 16 to 24 inches of panel. Okay? That's why you can't ship them, because you can't swedge the entire panel, only in the end. Stagger the seams with a fixed clip, because the fixed clip goes here where you fasten through. Again, you always shingle down slope. This testing is solid, okay? So if you have an 80-foot long building, you can't ship panels in that long without a chase truck and a flag and all that. Maybe you want to ship in a 50 and a 30 or 240s to hit that amount. You can lap metal panels. If you can't ship them in because the road restricts it with tight turns, or they're too long, or you don't want to take onto the cost of everything I went through with flagmen, site access, spreader bar, crane operators, 1 person per 10-foot stick. I mean, metal workers' wages can be upwards of $200. If you have a 100-foot long panel, that's 11 workers at $200+ a pop moving a panel, right? If you don't want that, lap them. All the testing's there. It's solid. Okay, fixed clip in the middle. Let's pretend that this is a big shed roof. Fixed clip in the middle, panel lap with your swedge marks. As you can see, the little ripples in the panel. Floating clip up slope, floating clip down slope. Now you're not limited on length. You're doing an arch. Fix it in the middle. Lap the panels. You want to know what a huge pain in the rear end is? Lifting a curved panel in one piece onto a roof. What if this thing is 60 feet on either side. That is a massively complicated lift to get it up there. Curve one side, lift it up, lap it in the middle. Done deal. Apex, float either side. Okay, drag loads. Drag loads are important. If you have a condition where you want to do a kneecap and you have a heightened drag load, talk to me offline. I can help you with how to do that because the panel must float up slope, right? Generally speaking, you pin at the head, you float down slope. Okay, penetrations. Push your penetrations as far up towards the ridge as possible in cold climates. This is why. If you push them up towards the ridge, only the snow at the ridge can get behind them. If they're down towards the eave, the entire length behind it up to the ridge is pushing on that and it will collapse your penetrations, okay? Make a steep roof, push them up towards the top. Hey, look at this. Here's your panel clamps that are used to put a snow divider so it doesn't collapse that penetration. You can use your panel clips for that. We'll add another thing to it, just not fall protection, right? Okay. Snow retention devices, again, same thing, set screw, you can use them, no problem. Okay, wide valley and inadequate valley width. So dead loads can crush ribs. You should have a solid substrate under there. The wide valley on the right, I want you to focus on, think of a freeway. If you merge onto the first exit on a freeway and you join the freeway, there's no traffic. The further down into the city you go with more people merging on, the more busy it gets. That's how runoff works. At the top of the panel run, there's two panels running in, one from this side, one from this side. It runs into the valley. Not a lot of stuff here. By the time you get down to the bottom, tick, 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 to the bottom, everyone's merging on. There's a lot more water near the bottom than at the top. So because of that, you may need to do a wide valley design in certain areas that have a lot of snowfall, a lot of snow melt, or a lot of rain. So keep that in mind because the seams divide that so the water can't go across, and as they join, more and more, right? Okay, pipe penetrations. Only fasten the pipe boot to the panel. Do not fasten the pipe boot to the substrate. Panels move. You fasten the pipe boot to the substrate, panel can't move. It'll do this. Okay, so a pipe boot is a slinky that the top stays stationary and the bottom moves with the panel. So cut the hole just big enough for the movement, put the pipe boot over it, fasten the pipe boot to the panel only. If the pipe vibrates or plumbing fixtures vibrate or a generator turns on or whatever, when it vibrates, it's okay. It's meant to do that, and it's meant to move with the panel. Top stays stationary, bottom moves back and forth with expanding and contraction. Don't fasten it to the substrate. I know it's basic, but it happens all the time. Okay, if you have a pipe penetration that is off to the side, where it's going to hit a rib, or it's in the middle of a rib, you use what's called a home plate detail. The home plate detail looks like this, because you can't put a pipe penetration there. Left, not good. Doesn't look good at all. All the water running downslope now hits an open seam. Just because you folded it over with some, pookie or some mastic in that doesn't mean it's going to be watertight. Don't do that. Use the home plate detail. Looks a lot cleaner. Okay. Pipe boot goes in the middle of the panel, so runoff can go around it. If it's off to the side or if it's on a seam, home plate detail. If it's more than 2 panel widths, use a curb. 1, pipe boot. 2, home plate. 2 or more, curb. Put whatever you want on a curb. Solar tubes, HVAC, ventilators, skylights, don't care. Curb them. Okay, they have pre-manufactured curbs as well that come with built-in crickets. Awesome. That's the end. Did I make it? 1 minute left. We're good, team. Let's do some questions.
Perfect timing. Okay, let's go back to section 2 for a second. What are the best colors to resist fading?
So with Kynar, with a Kynar paint system, the chalk fade qualities are all going to be consistent and uniform. All right. With a non-Kynar system, it's going to be your traditional colors and not your bright. So like white will stay, will not fade as quickly, or will fade less quickly as compared to a red. But the issue comes in with different paint systems. Like if you have a red or a brick colored roof with Kynar versus a polyester paint system, that will fade a lot quicker than Kynar, but Kynar is going to be uniform. So your color choice really doesn't matter to me as long as you use a Kynar based paint system with Kynar based flat sheet with the same paint system.
Okay, now going into section 3, is there a preferred detail to use for standing seam hip caps to avoid oil canning?
Okay, loaded question. So oil canning is defined under SMACNA as a measurable, repeatable process of roll forming. So oil canning to us is, did our roll former put a blip in the metal every 12 or 16 inches? Oil canning in popular nomenclature is like, if I go out and look at this building, does it look icky, right? Does it have a blip? Oil canning in our popular terms can be caused by a pop rivet, thermally locking it. It can be caused by incorrect trim, flashing. It can be handling, shipment, crating. If it's a flat panel versus a profiled panel, the flat panel doesn't have a predefined point where it's going to flex, so it'll flex wherever it can, versus a profiled panel that already has a predefined point. So my answer is a lot of those variables come into play with oil canning, and you have to take into consideration, I mean, even color, right? Which one will show an imperfection more versus a pop rivet that's in a different location. So there's a lot that comes in.
Is it possible to unseam damaged standing seam panels in the middle of the field for repair? If so, is there a recommended overage I should order from my project?
Awesome question. Yes, there is. You can unseam a mechanically seamed panel, but it will depend on if it's directional or not. What I mean by that is if it's a mechanically seamed panel where it rolls into the adjacent panel with no batten cap, you may have to take over everything to the side of it to get it in. If it's a batten seam, like a T-seam or a bulb seam where the panels come up, and then you mechanically seam a batten on top, you can zip the batten and replace the panels. So if it's a mechanically seamed panel with no batten, the answer may be 1 to 2 panels, upwards to a lot. If it's a batten mechanically seamed panel, it'll be 3 panels. Actually, technically 1 panel and 3 batten caps, because you can save the other 2 panels. But good question.
Okay, thank you, Jeff, for this excellent presentation. Just a reminder before, oh, sorry, that's all the time we have for today. If you need to reach out with any additional questions, Jeff's contact information is currently up on the screen. Just a reminder before everyone leaves, if you would like to rewatch today's presentation or share it with a colleague, we'll be emailing the link to the recording to everyone who registered within a week. Once again, it may take up to 5 business days if you're requiring a certificate, so keep an eye out on your inbox and don't forget to check your spam or junk folder. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey as it helps us to continue to serve your needs in the future. Thanks again, Jeff. Thank you everyone for joining us. Have a great day.